Have you ever wondered how computers seem to be getting smarter every day? How can they recognize your face in photos, predict what you want to watch next on Netflix, or even drive cars? The answer lies in a fascinating field called machine learning. Machine learning is like teaching a computer to learn from experience without explicitly programming every single step. Imagine showing a child a bunch of pictures of cats and dogs, and eventually, they learn to tell them apart. Similarly, in machine learning, we feed computers vast amounts of data, and let them figure out patterns and make predictions on new unseen data. This powerful technology is transforming our world at an unprecedented pace, and understanding its basics is becoming increasingly important for everyone, not just computer scientists. So buckle up, as we embark on an exciting journey to demystify machine learning and explore its three main types: supervised learning, unsupervised learning, and reinforcement learning. Get ready to be amazed by the power of data and algorithms. Let's start with the most common type of machine learning: supervised learning. Think of it like teaching a dog a new trick with treats. You give the dog a command, and if it responds correctly, you reward it with a treat. With enough repetition, the dog learns to associate the command with the desired action. Similarly, in supervised learning, we provide the computer with a labeled data set, where each data point is tagged with the correct answer. For instance, imagine a data set of emails labeled as spam or not spam. The algorithm learns from this labeled data to identify patterns and rules that distinguish spam from legitimate emails. Once the algorithm is trained on enough data, we can use it to classify new, unseen emails as spam or not spam with impressive accuracy. Essentially, supervised learning is all about learning from examples to make predictions about future outcomes. Supervised learning is everywhere, powering some of the most exciting applications of artificial intelligence. Here are a few examples. Image recognition. Ever wondered how Facebook automatically tags your friends in photos? That's supervised learning at work. By training algorithms on millions of labeled images, computers can now recognize faces, objects, and even emotions in pictures. Spam filtering. Tired of spam emails clogging your inbox? Thankfully, supervised learning algorithms have got you covered. They can effectively identify and filter out spam, saving you time and frustration. Medical diagnosis. Machine learning is revolutionizing healthcare by assisting doctors in diagnosing diseases more accurately and efficiently. By analyzing medical images and patient data, algorithms can help detect tumors, predict heart attacks, and even personalize treatment plans. Fraud detection. Banks and financial institutions use supervised learning algorithms to detect fraudulent transactions in real time, protecting you from financial losses. These are just a few examples of how supervised learning is making our lives easier, safer, and more efficient. Now let's move on to unsupervised learning, a slightly more mysterious but equally fascinating type of machine learning. Imagine you have a basket full of different fruits, but you don't know what they are called or how to differentiate them. Unsupervised learning is like giving this basket of fruits to the computer and asking it to group similar fruits together based on their characteristics like shape, color, and size. The computer doesn't have any prior knowledge or labels to guide it. It has to figure out the patterns and relationships on its own. In essence, unsupervised learning is all about discovering hidden patterns and structures in unlabeled data. It's like exploring a new planet without a map, relying solely on your observations and intuition to make sense of the surroundings. Section 5. Practical applications of unsupervised learning. Although it might seem less intuitive than supervised learning, unsupervised learning plays a crucial role in many real-world applications. Here are a few examples. Customer segmentation. Businesses use unsupervised learning to group customers with similar purchasing behaviors, demographics, or interests. This helps them tailor marketing campaigns, personalize recommendations, and improve customer satisfaction. Anomaly detection. Imagine you're monitoring a network for unusual activity. Unsupervised learning algorithms can learn the normal patterns of network traffic and flag any deviations, potentially identifying cyber attacks or system failures. Recommender systems. Ever wondered how Netflix suggests movies you might like? Unsupervised learning algorithms analyze your viewing history and preferences to recommend movies with similar themes, genres, or actors. Data pre-processing. Before applying supervised learning algorithms, it's often beneficial to use unsupervised learning techniques to clean and prepare the data, identify outliers, and reduce dimensionality, leading to better model performance. Unsupervised learning is like a detective, uncovering hidden patterns and insights that would otherwise remain hidden in the vast sea of data. Section 6. Delving into the world of reinforcement learning. Finally, let's explore the most intriguing and perhaps the most complex type of machine learning reinforcement learning. Imagine teaching a dog a new trick, but this time, instead of giving it treats, you only tell it if it's doing well or not. The dog has to learn through trial and error, adjusting its actions based on the feedback it receives. Reinforcement learning is similar. We let the computer interact with an environment and learn by trial and error. The computer takes actions, receives feedback in the form of rewards or penalties, and adjusts its strategy to maximize rewards over time. Think of it like playing a video game. The computer is the player, the game is the environment, and the goal is to achieve the highest score. Through repeated gameplay, the computer learns which actions lead to positive outcomes and which ones to avoid. Section 7. Reinforcement learning in action. From games to robots. Reinforcement learning might sound like something out of a science fiction novel, but it's already having a significant impact on various fields. Here are a few examples. Game playing, reinforcement learning has achieved superhuman performance in games like chess, Go, and even complex video games like StarCraft. These algorithms learn optimal strategies through self-play, pushing the boundaries of artificial intelligence. Robotics. Robots are being trained using reinforcement learning to perform complex tasks like grasping objects, navigating unfamiliar environments, and even collaborating with humans in industrial settings. Personalized learning. Imagine a learning app that adapts to your pace and learning style, providing personalized exercises and feedback to help you master a subject. Reinforcement learning can make this a reality, revolutionizing education and training. Resource management reinforcement learning is being used to optimize resource allocation in various domains, from managing energy consumption in smart grids to controlling traffic flow in cities, leading to increased efficiency and sustainability. Reinforcement learning is like giving machines a sense of agency, allowing them to learn and adapt in complex, dynamic environments. Section 8. Recap the essence of machine learning. We've covered a lot of ground, so let's recap the main points. Machine learning is like teaching computers to learn from data without explicit programming. Supervised learning. Learning from labeled data to make predictions, for example, image recognition, spam filtering. Unsupervised learning. Discovering hidden patterns in unlabeled data, for example, customer segmentation, anomaly detection. Reinforcement learning. Learning through trial and error by interacting with an environment, for example, game playing, robotics. Each type of machine learning has its strengths and weaknesses, and they are often used in combination to solve complex real-world problems. Section 9. Machine learning, shaping the future. Machine learning is not just a futuristic concept, it's already transforming our world at an unprecedented pace. From healthcare and finance to transportation and entertainment, machine learning is revolutionizing industries, creating new possibilities, and raising profound questions about the future of work, ethics, and society as a whole. As machine learning continues to evolve, it's crucial for everyone to have a basic understanding of its capabilities and limitations. By embracing this transformative technology responsibly, we can harness its power to solve some of the world's most pressing challenges and create a brighter future for all.